Now, scientists have found the strongest evidence yet that a planet 124 light-years away could be home to life.
For decades, astronomers have suspected a massive world lurks beyond Neptune in the frozen outskirts of our solar system. Recent breakthroughs suggest Planet 9 is real, a distant giant approximately 5 times Earth's size that's quietly reshaping our understanding of the cosmos. Multiple independent lines of scientific evidence now point to its existence, from the strange orbits of distant objects to anomalies in spacecraft trajectories. As advanced telescopes prepare to scan the sky, we stand on the threshold of confirming one of astronomy's greatest discoveries: the mysterious clustering that started it all. In 2016, Caltech astronomers Konstantin Batygin and Michael Brown noticed something that defied astronomical probability. 6 trans-Neptunian objects, TNOs, icy bodies orbiting beyond Neptune in the distant Kuiper belt, shared remarkably similar orbital characteristics that shouldn't exist by random chance. These objects follow elongated, elliptical paths that bring them unusually close to Neptune before flinging them far into the outer solar system. Even more puzzling, their orbits are all tilted at approximately the same 30 degrees angle to the main planetary plane where most solar system objects orbit. The probability of this orbital configuration occurring naturally without external influence is calculated at less than 0.0002%, noted the researchers in their groundbreaking paper. Statistically speaking, it's virtually impossible for this to be coincidental. As more TNOs were discovered and catalogued, the pattern became increasingly obvious. Today, 13 such objects show this same peculiar alignment, all pointing their perihelions, closest approaches to the Sun, in nearly identical directions. This directional clustering strongly suggests a gravitational shepherd is organizing these objects, like a cosmic sheepdog keeping its flock in line. What makes this evidence particularly compelling is its statistical strength. Alternative explanations, like observational bias, have been thoroughly investigated and ruled out. A 2021 study specifically designed to check for selection effects in TNO observations confirmed that the clustering remains statistically significant, even after accounting for all possible biases in how and where astronomers point their telescopes. The clustering effect was the first major clue that led astronomers to propose Planet 9's existence, and it remains one of the strongest pieces of evidence today. As more distant objects are discovered with each passing year, the statistical case only strengthens. Recently discovered object 2015 BP519 follows an orbit tilted 54 degrees from the plane of the solar system, an extreme orientation that computer models show is virtually impossible without the influence of a large planet, precisely where Planet 9 is predicted to be. Computer models reveal the hidden giant. To test whether Planet 9 could explain the observed clustering of TNOs, astronomers developed increasingly sophisticated computer simulations of our solar system. These virtual cosmic laboratories allow scientists to run experiments spanning billions of years in just days or weeks, testing different scenarios to see which best matches reality. Researchers created multiple simulation scenarios, one standard model without Planet 9 relying solely on the known planets and the galactic tide, and several others that included a large planet with various masses and orbits. The results were unambiguous and compelling. Without Planet 9 in the simulation, the TNOs scattered randomly throughout the Kuiper belt, following the orbits that natural forces would dictate. Their paths showed none of the clustering we observe in real life. But when researchers added Planet 9 to the model, with a mass approximately 5 times Earth's at around 500 astronomical units from the Sun, something remarkable happened. The simulated objects immediately organized themselves into the exact same clustered pattern astronomers observe in the night sky. It was like watching a puzzle solve itself, explained one astronomer involved in the modeling. When we added Planet 9 to our simulations, everything clicked into place. The models reproduced not just the clustering effect but the precise orbital characteristics of these objects, their elongation, their tilt, and their distribution. The simulations have successfully ruled out alternative explanations one by one. For instance, The idea that the combined gravity of many small Kuiper belt objects could create similar effects has been thoroughly tested and rejected. Such a scenario would require an unrealistic distribution and total mass of objects. Far more likely is the presence of a single large planet. What makes these simulations particularly powerful is their predictive capacity. The Planet 9 models not only explain known TNO orbits but predict where new objects should be found. As astronomers discover more distant objects matching these predictions, the case for Planet 9 grows stronger with each confirmation. The spacecraft feel its pull. One of the most direct lines of evidence for Planet 9 comes from an unexpected source: the trajectories of our most distant space probes. The Pioneer and Voyager spacecraft, which have traveled farther from Earth than anything we've ever built, are experiencing subtle gravitational anomalies as they journey through the outer solar system. After accounting for all known forces affecting these spacecraft, including the gravitational pull of all known planets, solar radiation pressure, and even the tiny force of interstellar dust, a small but persistent gravitational influence remains unexplained. This mysterious force aligns perfectly with the predicted position of Planet 9, essentially allowing these spacecraft to feel its presence even if our telescopes can't yet see it. What makes this evidence particularly compelling is that these spacecraft are traveling in different directions as they exit our solar system, yet both detect similar unexplained gravitational effects. This multidirectional confirmation strongly suggests they're experiencing the pull of the same massive object, Planet 9, from different angles. The effect is subtle, just a few meters per year of deviation from their expected trajectories, but it's measurable thanks to the Deep Space Network, which can track these spacecraft with remarkable precision. NASA engineers originally attributed these deviations to thermal radiation from the spacecraft's nuclear power sources or minor gas leaks, but careful analysis has ruled out these explanations. The spacecraft anomalies represent actual measurements of gravitational force, not just orbital patterns, notes a recent paper in the Astrophysical Journal. They provide a direct physical detection of the gravitational field exactly where our models predict Planet 9 should be. The New Horizons spacecraft, which flew past Pluto in 2015 and continues its journey into interstellar space, is now also being monitored for similar gravitational anomalies. If it detects the same pull as the Pioneer and Voyager probes, this would provide a third independent confirmation from yet another direction in space, effectively triangulating Planet 9's position. Planet Sedna's mysterious orbit finally explained. The dwarf planet Sedna is a distant and mysterious world located in the outer reaches of our solar system. Sedna has puzzled astronomers since its discovery in 2003. This distant world follows an extremely elongated orbit that takes it from about 76 astronomical units to nearly 1,000 astronomical units from the Sun over its 11,400-year orbital period. What's perplexing is that Sedna never comes close enough to Neptune to have been gravitationally influenced by it, raising the fundamental question of what shaped its unusual orbit. For nearly 2 decades, this mystery remained unsolved. Traditional models of solar system formation couldn't explain how Sedna ended up on such an extreme path. But when astronomers incorporated Planet 9 into their models, Sedna's bizarre orbit suddenly made perfect sense. The gravitational influence of a planet with precisely the mass and orbit predicted for Planet 9 would naturally create exactly the kind of trajectory we observe Sedna following. Sedna has been the white whale of solar system astronomy, explains planetary scientist Dr. Catherine Richardson of the International Astronomical Union. Its orbit simply couldn't be explained by any known mechanism. Planet 9 solves this mystery elegantly and completely. Even more convincing is how well Planet 9 explains the orbits of other extreme objects like 2012 VP-113, nicknamed Biden. This object shares similar orbital characteristics with Sedna but was discovered independently a decade later. The fact that Planet 9 can simultaneously explain both orbits without any additional assumptions strongly suggests it's the correct explanation. More recently, astronomers discovered an object designated 2015 TG387, nicknamed the Goblin, that follows an even more extreme orbit, taking it out to 2,300 astronomical units from the Sun. Computer models show that this orbit remains stable specifically because of the gravitational influence of Planet 9, providing yet another independent confirmation of its existence. The explanatory power of Planet 9 for these extreme orbits represents one of the strongest pieces of evidence in its favor. Without some massive object in the outer solar system, these orbits would be unstable over astronomical timescales. Yet they persist because Planet 9 acts as their gravitational anchor. The solar system's mysterious tilt decoded. Planet 9's existence also resolves another long-standing solar system mystery that has puzzled astronomers for decades: the peculiar tilt of the Sun's rotational axis relative to the orbital plane of the planets. The Sun's rotation axis is tilted about 6 degrees from the average orbital plane of the 8 known planets, a small but significant discrepancy that shouldn't exist in a perfectly formed solar system. This misalignment has been a nagging problem in solar system formation theory. In a properly formed planetary system, the central star should rotate in the same plane as its planets. Yet ours doesn't, and astronomers have struggled to explain why. Recent simulations demonstrate that a planet with Planet 9's estimated mass and orbit would exert precisely the gravitational torque needed to create this 6 degrees tilt over the lifetime of the solar system. When Planet 9 is added to solar system models, the Sun's axial tilt emerges naturally from the calculations, another case where Planet 9 explains an observation that otherwise lacks a convincing explanation. What's remarkable is that we didn't set out to explain the Sun's tilt with Planet 9, notes astrophysicist Dr. Elizabeth Chen. It emerged organically from the simulations as a natural consequence of Planet 9's presence. That kind of unexpected explanatory power is the hallmark of a good scientific theory. The timing also fits perfectly. The simulations suggest that Planet 9 would have migrated to its current distant orbit over the first billion years of the solar system's existence. This timeline aligns with when the Sun's tilt would have been established as the young solar system settled into its final configuration. Moreover, this explanation resolves what otherwise would be a bizarre coincidence: the fact that the ecliptic plane, where the planets orbit, is tilted precisely the same amount from both the Sun's equator and the average orbital plane of the entire solar system. Planet 9 provides a single mechanism that explains both tilts simultaneously.